Section 3.1 is using graphs to solve linear systems. Remember that a system means two or more equations. Linear means that they're going to be equations of lines. So we have two equations of lines here. If we're going to solve by graphing, we graph each of them separately, and then the solution is points that they have in common. So it's going to be where they intersect. This first one, I'm going to switch the y, or the x and the 10, so that it's in mx plus b. Second one, I'm also going to solve for y, so I'm going to move the 3x over. Negative 3y equals negative 3x, and then divide them both by negative 3. So y is equal to, that's positive 1, x, you get y equals x. So if y is equal to x, that's your m, x, and your b would be 0. You don't have to write that part, I'm just writing it in there to try to be helpful for you. So if I graph the first one, it starts at 10 on the y-axis, that's the y-intercept, and it has a slope of negative 1. So if I want to write that as a fraction so I can do rise over run, it's down 1, right 1. So down 1, right 1, down 1, right 1. And I'm going to line those up and graph that line. Okay, there's the first one. The second one has a y-intercept of 0, so that means that it starts at the origin. The slope is positive 1, so I'm going to write that as 1 over 1 so that I have a fraction to do rise over run. Rise 1, run 1, rise 1, 1, run 1. And then I'm going to draw that line. So the solution means what points do they have in common. That's where they cross right here. We're looking for that point. And we want to write it as an ordered pair. We need an x coordinate and a y coordinate. So if you just count 1, 2, 3, 4, 5 is the x coordinate, and 1, 2, 3, 4, 5 is the y coordinate. Remember, you can plug them back in to check. So if I plug 5 in for y into either one of them, equals 10 minus x. The x coordinate's 5. Does that check out? 5 is equal to 10 minus 5. It does work, so it looks like our solution is good. Don't forget to write your answer as an ordered pair.